Hello and welcome to the world of parallel programming. So far here, as we discussed last time about the hello world, and we know how we can write our basic parallel programming code. And if you are here so far, then you are quite enjoying the code and you are enjoying what is a parallel programming and programming the parallel computing. So with that in mind, so let's dive into the more details and let's enter the programming. So in the last session, what we learned about is how we can write a simple kernel for the Hello World program into the GPU and how we can invoke it. Now, we are going to know there is more than one ways through which we can invoke the same code. So, as we can see here, so this is the same kernel space which is written as a globally available to both device and the host driver. And now when we come to over here, so the first way to invoke is with the directive. So this is called as a triple Chevron syntax. So that is what we used in the earlier session. However, we directly used what is the size of a blocks and the size of threads, and we directly passed it. Now, what comes into here for kernel invoke is that not only just a block and a grid, but the block and grid goes as a three-dimension index. So if you recall that we were having a matrix X, Y, and Z in our hardware architecture, and this is how we can specify. So the dimension X we are specifying as a total blocks, which is a 2, and then rest of the dimension as a 1, 1. Okay, the same goes for the threads per block, which is we are defining as 4. Then it would look like a 4, 1, and 1. And the, this is another parameter which is called out as a number of bytes we need to allocate as additional shared memory for this kernel. And we can also specify our customized stream ID to allocate our workload. So this is a streaming processor, and that stream ID we can actually allocate and have a proper control over to the stream. Now that was just one way of writing a code and invoking the kernel. But as you can see, the another way is through the macro. So the hip also provides a macro known as a hipLaunchGGL. So this is a macro function. What it takes is it takes all the parameter what we have seen in the triple Chevron syntax, but because it is through the macro kernel, it takes a first argument as actual kernel function name. So we are calling a macro with the actual kernel name, and then we are providing the same values of our blocks, threads, we are providing extra shared memory, and we will also providing the heap stream ID. So let's try to see like how we will be able to launch. So let's see over here. So if we want to run a code, so we can just run hipcc and again hello world. So before that, we need to go to this directory. So it's easier and hipcc hello world explicit.cpp-o hello world explicit. So let's say this would be our compiled file, and we can just launch. And as you can see, so what it has launched is it has launched the kernel with this is a stream ID, what we have declared. So if you see, this is a default stream ID, but here we have overridden that stream ID with the hip stream create function. And you can see the stream ID for the first one and the stream ID for the second microkernel is happen to be different. Now, if you observe hip device synchronize, if we comment this block out, then let's see what you see. Then what you may end up seeing would be the different output. So as we can see that we have paused the synchronization, but as we can see, because we have created a different stream ID, this is still taking care and it's not clubbing the jobs. Now let's see, what if we also ignore this new string creation? Then what happens? It would allocating the data on the same string. Okay, to compile it again, recompilation, and then rerun. And you can see now. So if you notice over here, what just has happened is the workload created this stream ID. It has allocated the workload to the device, and then it is not created a new stream ID. It has just offloaded the same new workload on the same stream ID. And because of that, as you can see, that we are seeing this kind of a clubbed output and where the data is not synchronized. So in that event, we can use this data synchronizer and just make sure that we have it in the order like this. So even in the stream ID. So thank you for watching this video and stay tuned for more updates and happy programming.